just a thinking approach that you need to grasp. So I know I'm not as funny and smart as Juan and Zizi. So I need to make sure you like me. So I brought some food from Trader Joe for today. And as a way to make this very, very technical lecture a little bit funny. So that's about today. So today we will talk about, we already talked about green buildings and healthy buildings. Now we're going to talk about how to quantitatively measure the benefit of the green building or the green city, and how to do a model. But don't be so worried, and this model is so simple, and I'm sure you can understand. So just to quickly recap. The quickly recap is the following. So for the entire this course, we talk about the business case, right? We talk about business case. Our point is, you can also think that's just for people, for the planet, with 3 bottom lines. And a very, very important bottom line, the circle, is profit. So we need to understand whether there's a profit in the market that can incentivize the different stakeholders to build and supply, to own, and to occupy the green and healthy buildings. So that's a cash flow I don't need to go through. But when I went through this in my first and second green building lecture, I just showed you some papers, right? Scholarly work, some literature. That's a literature to show, oh, there's a green premium, and here is the tenants, they are willing to pay higher rent, or the buyers, they are willing to pay higher price. And then I show you this. Remember the rental premium of the green buildings. So I say, oh, these are all the studies, and the Siqi studies here. And from all the studies, I give you a takeaway message, which is a significant rent premium of the green buildings, about 6%. And there's some distribution, there's a range. So how did these scholars, how did these researchers got to this conclusion of the 6% of the premium? That will be our today's focus. And we also saw some like this price premium. This price premium say, oh, these all the papers, and the price premium overall is some negative, some positive, some significant, some not significant, but overall is 7.6%. So that's basically today's topic, is how to understand this premium and how to quantify. So our outline is the following today. First, I will still talk about the green building as a starting point. But since this is the methodology, this can apply later to all kinds of things. Healthy building and all the climate resilience, all kinds of things you want. How to quantify the premium. And then talk about some cities. If you understand the green building part, the green city is very easy. And I will talk about some little bit how to apply that to business and policy decision making if we can estimate that premium. First, has anyone heard of this hedonic pricing model? Raise your hand if you have heard of this terminology, hedonic. Have you ever used that in your research? Or not research, like PSAT exercise? Okay, Wilson, what kind of PSATs you did? In Wisconsin medicine?
No. Your research assistant for papers, so I kind of like dig into them.
Okay, from your research assistant work with me. Okay, good to know. Okay, so this is my, I use hedonic pricing as a way to make a living. So my papers, so that's why. And so here, after today's lecture, you need to understand this. And you should be able to use that. So that's the point. But first of all, I want to give you a big picture of this. So basically, when we want to say, okay, now we want to understand there's some benefit. This benefit is not market good. If this is a market good, like a coffee, like a computer, we can observe its price easily from the market. But if this is non-market goods, like clean air, non-market goods, right? So this carbon, until its price, is non-market goods. Global warming, non-market. You cannot really observe the price of those non-market goods. So So there are two ways. There are two ways to derive indirectly the people's willingness to pay. So that's the first terminology. I want you to understand this is a willingness to pay, WTP. We will see a lot of these words today. That's why I need the blackboard here. Consumers, no matter it's buyers or tenants, willingness to pay for something. So there are two ways to derive this. If you cannot observe from the market, one is called stated preference, the other is revealed preference. To help you memorize this, stated preference basically talking. You talk, you speak. And revealed is doing. One is talking, the other is doing. So today we will focus on the doing part, but I want to give you a sense of the talking part. Okay, so basically this short video gives you a sense of this willingness to pay by talking. So I have done this for many times for my own research. For example, I send students to survey these residents about their willingness to pay for green building. So that's kind of, I think basically in your thesis later, maybe you can also apply this method if you want to do a survey and ask. But today, this is not our focus. Because as just mentioned in the short video, this talking is not reliable for many, many reasons. If you think, oh, if the respondent says, oh, you asked me willing to pay for any public policy to reduce air pollution or all things, and later you use as evidence to increase tax, then they have a tendency to lower their willingness to pay, right? If they think they can just be free riders, so they will increase their willingness to pay as a pressure to others to get this done. Now, housing market or real estate market really provide us a very much better opportunity for this, just by doing. This is hedonic. So it's not about talking, but we observe from the real estate market of the real transactions, price, rent, and you start to back out people's willingness to pay for market or non-market attributes. So that's the point. So why housing market provides us a better opportunity? That's because I think all of you understand that housing market, when you buy a house, it's not just the structure itself, right? It's not the concrete, it's not just the columns and the walls and the windows. No, you are buying a place to live, and you are buying that neighborhood that you want to access to many, many opportunities. So that's the point of housing. Housing is so important, that's location-based, and you buy or rent a house for so many other things. It's not just the rooms or the kitchen or the walls or the space. So that gives us a way to decompose, using the housing transaction price to decompose why people are buying this house, particular location, right? So I give you a very simple example for you to understand this. For example, there's a single family house, $1 million. $1 million. And actually, why this buyer is buying this house by $1 million? Because of course we have, the household has 2 kids, and then they need 3 rooms. They need 3 rooms, they cannot live in a very small place. So that's 3 rooms, that's a component, that's very tangible. And then the household also want to live in a place very convenient. So this household want to pay for this location because there's 2 subway stops nearby, for example. That's a hypothetical example. And then it's so convenient, then they are willing to pay $1 million for this accessibility to subway stops. And then there's such a nice park nearby. This household really like park. So the household want to buy this location because $1.1 million to pay for the park. And plus all this, another thing is this is a green building. Suppose this household really want to pay for the green building, so they, because of the green building, they also want to get $1.1 million. So of course, this is 4 examples. 4 examples of the real space of the house, transportation, accessibility, some environmental, park, and a green building stuff. So that's the 4 things. I give 4 examples. However, there are so many other things. There's thousands of things related to this house. We cannot do all this. Then we always have this last component called residue. It's a residual. It's like a trash can. It's all the things you cannot observe and you cannot measure, but the household must value those things go into this. Suppose that it's 1, 1. So then you clearly can see this is hedonic model. Hedonic model is decomposition. And you decompose a very complex thing, which is a house. It's a complex commodity, into many pieces, a bundle of pieces that you are using money to buy. Now, I just randomly give you some numbers, but there's a scientific way to estimate this, right? So I just throw out these numbers. Of course, cannot be doing this. Scientific way is to estimate. So how to estimate? That's a hedonic model. So that's the following. 1 million on the left-hand side, that's the total price, total willingness to pay. Then decompose to now 4 components plus a trash can. These 4 components, for each component, there's a unit price times quantity, right? As when we buy apples, you have unit price and you have quantity, how many apples. So that's the same thing. So basically, for 3 rooms, each room 0.2 million. 2 subway stops, each subway stop 0.05 million, right? Then the lead is a kind of one thing, one tangible thing. And then 1 nice park. If you have 2 nice parks, that will be 2 parks, but now it's one park. So that's a way to decompose the price, total value, to 4 components plus a trash can, and each component you have price and quantity. So that's clear. So that's a way. And how you get these numbers, then this is a model. This alpha is the unit price. X is the quantity you have 4. How to estimate unit data? You cannot just randomly come up with numbers without any data. You have input and output. So the way to do this is to do a regression. Actually, we will tell you more. Yesterday, did you cover regression? No. Next recitation. Regression, for example, we cannot just get 1 house. If you can only get 1 house, you cannot do this. You need thousands, hundreds of thousands of observations. Now we have all big data. We have zero. Actually, we'll share with you some zero data. So the zero data, we will get the transactions, housing transactions in Seaport area and the downtown Boston area. Suppose you get 1,000 observations of the transactions. Then the blue boxes are the input. For each transaction, you will have the total value, transaction price. You will have those quantities, right? You know each house is 3 bedrooms, 2 bedrooms, or 1 subway stop, 2 subway stop, or 0 subway stop, and whether it's lead or not. So you have the input of the quantity and the total price. Then you throw the data into software, which is R. And then the software will report this coefficient. These red things are reported from the software where if you feed all the transactions into that. So that's a regression. Then the point is, from all those 1,000 regressions, you get P, x1, x2, x3, x4, then you run, then you get alpha 1, alpha 2, alpha 3, alpha 4, right? And it also reports R square. What's this? You know? Okay, please.
The higher the R squared, the higher the correlation of the variables to the law.
Yes.
The dependent variables to the independent variables.
Good. Yes. This is called this explanation power of this equation. So we want this to be as high as possible, but we are not so cannot go to 100%. So this 83% means these 4 variables can explain 83% of the variation among all those observations. 17% is in the trash can. So this basically 17% is here because it's other things you cannot observe. So that's the point of the hedonic. Easy. So that's basically today's point. And then, of course, there's many, many complexities behind this, but this key thing is here. And when you do the real regression, it won't be 4, maybe 5, 6, no matter what. And always, when you do this, you are not like without purpose. When you do this, you always have a purpose, right? purpose can, in general, you want to do an exercise, or you are mostly interested in one coefficient. For example, if I was a researcher to do this, I want to understand alpha 3. I want to understand alpha 3 is people's willingness to pay for a lead building. So this willingness to pay, and it can be many willingness to pay. Now we have 4. 1, 2, 3, 4, right? I'm most interested in 3, which is the lead. Of course, I want to get alpha 3, I must first run this and get all these alphas, then I focus on alpha 3. Others are byproducts, right? For example, there's a transportation researcher, Mackenzie is a transportation researcher, then she is not interested in alpha 3. She is interested in alpha 2, right? The accessibility to subway stop means what, right? So then later can relate to other policies. A little bit of algebra, but not so difficult. So when just now I see a very intuitive way to decompose, right? When you read papers or any research piece, you will see such a model in this way. That's vectors. Always they take log because it's nonlinear. Log price as a function of some components. X1 now is a vector. This is the physical attributes. X2 may be locational attributes. Maybe each vector has several variables. Number of bedrooms, number of living rooms, and whether it's detached or attached. That's physical things. So you have physical, a basket, and some locational, a basket, like that. Then since this log, how to interpret the log, and just now I show this level. It's no log thing, right? Then you have the absolute value of this. That's easy to understand. When you take log on the left-hand side, how you interpret the coefficient as a small test of your math? Yes, yeah, percentage change, right? Yeah. So for example, you can tell me, look at this, and this is a hypothetical log price is like this, and I will ask if, let's say, living rooms. Number of living rooms, if there's an additional 1 living room, that will increase housing price by how much? 5%.
Oh, yeah, 5%. Yeah.
Yes, so this one will become percentage because we all know that log y, basically that's this. That's a basic thing, right? Then you take derivative, then this part will become the percentage. So that's basically start y divided by y, that's a percentage, right? So this beta thing will become percentage, which means incremental 1 unit increase. One actual living room will lead to a 5% increase in housing price. And this 1 green park, then you will increase by 5%. So that's an explanation of this when we take log. Because when we look at all these empirical studies, that's all in log. It's not in level. Here, this is the real paper. So you can see the real paper, that this paper is by this 2009. And then they say, okay, all other variables, all controlled. There's so many other things. And this is all other variables controlled. Then one variable called lead. And the other is called energy star, right? So remember, if like number of rooms, that's a numerical variable. Then you say 1 room, 2 room, 3 room. Sometimes it's a dummy. It's a dummy variable. It's dummy. It takes only 2 values, 0 or 1, right? And then, for example, in this example, subway is a dummy. I say dummy means within 1 mile subway buffer. If this house, this is a subway, and this 1 mile, the house is here, then it takes value of 1. If the house is here, it takes value of 0. So that's a dummy. So if the dummy, then the coefficient means from 0 to 1 change, that will incur the housing price increase by 8%. So that's a dummy. So based on this principle, how to interpret the lead coefficient of 0.06. Its lead is a dummy, right? Okay.
If a building is lead, it will increase your price by 6%.
Good. So that's why from all the empirical studies, we got all those coefficients. Then Energy Star, similarly, say also 6% price premium. So that tells you how those papers estimate the price premium by these hedonic regressions. The point is decompose, right? They decompose all the housing values, then they have all other attributes, and the coefficient of lead is 6%. So that's a price premium. It's not difficult at all. Then a little bit go back to the Winthrop Center. That this is a teaching case, right? Remember that? And at that time, let me see. You cannot see. This is a building, right? The lower part is a condo, office. The upper part is a condo. We talk about this a lot. And we have Brand, our guest speaker, came in. And we understood that for the lower part of office, they chose very, very green, a much higher level of energy efficiency, passive house. For the upper level, they didn't, because they need to keep the view and they don't think that's important. Of course, I don't think they run the hedonic when they made this decision, but we can think through this in our way. For example, Winthrop Center's team, Brand team, can collect the data of nearby. That's Boston area. If they can collect data from nearby office market and condo market, because Winthrop Center is still under construction, they don't have their own transaction price, but they can collect nearby these comparable properties. For example, they collected and they run this regression like the following. I show this. Of course, there's so many other things, right? And for the upper part, the condo market nearby, they run this. They got this. This is I made up. Just want to show the logic. And then the low is like this. Okay, if they say like, oh, for the upper part, these condo buyers value view so much, right? Compared to the lower part, because lower part no view. Remember, ugly buildings nearby. So this coefficient 0.3, this coefficient 0.01. So which means the people's willing to pay for view is so high compared to the lower. However, if the lower part, the green and the house, they have much higher willingness to pay compared to the condo, right? This is the relative magnitude of the coefficient can tell you what is the comparative advantage of that part of those attributes. Then this can justify why they chose the view as a comparative advantage, because much higher willingness to pay, but for lower, they chose green and house as the important attributes. So that's an example how the market analysis can use hedonic model to assist their quantitative judgment. Okay, now challenges. Wilson, you have a question?
No, just answer like major challenge.
Okay.
There's not a lot of idea like how to put in the health component. It's not common like passive housing in Boston areas, so they may not have enough data to actually get a correlation between the.
Yeah, the challenge is that you don't have enough observations, right? Because at that time, passive house was still very new, and maybe you couldn't gather enough observation. That's a very real challenge. But besides this practical challenge, suppose we can get a lot of observations. And do you think this kind of thing to derive the coefficient has a challenge? Other challenges?
I think it also depends on how you define your variables. For example, you're not controlling for a level of quality of the building. You're just saying it's lead or not. Maybe you're measuring the quality of the building with lead certification. And it's getting confused. So it's how you define it.
You are saying, although they call themselves lead, maybe they don't have that lead specific real features.
Maybe if you're controlling for, let's say, 3 variables, lead, view, and health, maybe the lead variable is not giving you the value of the lead building, it's only giving you the value of a new prime building.
Prime building like class A, like that, right? Exactly. How to call this problem?
I don't know.
How to call this problem? Just saying that it's a challenge that may lead, not just a lead, but also other things bundled into lead. The lead buildings newer, the lead buildings like these famous developers and those kind of things. How to call this?
Omitted variable bias.
Good. Okay, so I call it in a very, very intuitive way. It's called, this is not an apple-to-apple comparison. This is an apple-to-orange comparison. So that's why I got this Trader Joe thing, because I want you to understand this apple-to-orange comparison. And if you answer my question correctly, I will give this to you. So now I put here. Apple to orange comparison, I look at this paper. Look at this paper. This is a very famous paper of the, one of the very early paper of the green building thing. And they collect data of the United States. And then, of course, they collect some green building data, and then they collect nearby building data because they need observations, they need data. And then they give this table. It's too small, but I want to show you that they first compare. Treated buildings means green buildings, lead buildings. Control buildings means nearby non-lead buildings. That's a terminology. I need to put the terminology here so that you can remember control. Treated means the thing that we are studying, which is green. Control means others that are not green. Then they compare. Okay, it's of course. They say, oh, the rent treated is so high, much higher. However, we also observe Class A percentage. The treated green buildings, 75% of them, they are Class A. Only 25% of the control Class A. Age, the treated buildings on average 24 years old, and the control 53 years old. So that gives you a sense. They are not the same thing, they are not the same animals. This apple and orange, right? So that's an apple and orange comparison. So in our sense, think about this. We observe, oh, this is a green building, that is a non-green building. The price difference is like $1 million. It's a lot. However, how can we so confident? How can we be confident? That's because of the greenness. Because the green building also located in such a beautiful neighborhood, trees, a green park, and all the things. This building is such an ugly place, and a factory and pollution, all the things nearby, not compared. And so then that's basically the problem. How to better get from this apple to orange to get an apple to apple. This is do you have any answer for that? Okay.
You would want to compare buildings that were built in the city or close by, and then also you'd want to get the percentage of Class A buildings closer to the two sample sets.
Okay, you said close by, that's basically location difference, right? You won't get this one is a nice neighborhood, the other in a factory neighborhoods. But you said even nearby may be different, right? It's the old and the new one, how to do.
Right.
How to do this. Even nearby, two adjacent buildings, one is new, the other is old. But this one is for you. Okay, because I have several. Okay, this one, yeah, please.
Wouldn't there be a way to kind of normalize it so you compare buildings that are old with the same conditions and then just kind of discount it so that you're not comparing like the same figures, but you're comparing comparables and you can still use an older building?
Okay, your point. Could you repeat? Well, how you?
I don't know exactly the method,
Okay,
but, like,
you just want to make this normalize. Yeah, normalize away. Okay, this one. Yeah, normalize is a point. And then this one is for you, and I run out of, please.
You want to add as many variables as you can to make sure that you're comparing the
Yes.
same product. So you're going to add in the room count, like you were saying, the relative age, condition of the exterior envelope, which is the interior, et cetera, et cetera. So you have a bunch of data points, and then you can look at the relative value of each of those individual data points and see how it fits into the larger formula.
Good. So we should add as much as possible the controls. We call it controls, right? We can call these control variables. But as we know that always something in the trash can, because it's so much difference, and how can you control? So now I'm moving on a little bit, and I still need apple to orange. And we have 2. Okay, now this thing is called causal inference. This I think you really need to understand. Although maybe you don't want to get technical details, but the terminology and the thinking. Causal inference. Whether it's just a correlation or it's causal. We want causal. We don't want to just play with the correlations. And the causal inference, the challenge is we cannot observe the counterfactual. This is the new terminology, counterfactual. Counterfactual like something in your dream you really want, but you cannot. That's a counterfactual. And I will try to show this. Let me see. Okay, compare. Lead building, for example, this is a green building, and another brown building. That's a treatment, this is control. Then we know lead building in a place so good that I put a small green tree to show this nice neighborhood. And the green building, the brown building, the ugly, ugly place, rocks and random things, right? So now, if we compare these two, we know these are different. This is orange, this is apple, cannot. 2 different animals. And then how can we do? Ideally, we want a counterfactual. This is called counterfactual. This is in a dream, not real. This counterfactual is all other things are the same as this real one. This is a trick here. All the same as this one, but the only difference is whether you are green or not. The nearby things, the size, and all things, that's called counterfactual. But of course, let's see. I have this one. This is, and then we know we want this one. All else equal, the effect of lead is this real lead minus counterfactual, right? So that's a real thing we want. However, we don't want this. This is called bias. Bias means this brown building and that brown building, they have different other things. That's called bias. Bias is disturbing us from reaching the real result. Okay. Algebra, difficult. And so small you cannot see. But just want to tell you, but then to make sure you understand, I use my fruits from Trader Joe for you to understand. And later, after many years, we will think about the causal inference, think about Siqi and the fruits. Okay, then you understand, remember. So, now the following, it's a lot. This green lead building, see, this is green apple, lead, green apple, green. This is orange, totally different thing. Now, we need to create a counterfactual, which is also apple, same animal, same fruit, apple. But this is a red apple or brown apple. So this is a counterfactual, right? So these are 2 real things. This is in dream. This is dream. We observe these 2. But we know these 2 are different. Now, we make up one thing, is a counterfactual, the same animal, but the only difference is the color. Okay, so that's the point. The difference between these 2 are the real effect of lead. Understand? And these 2, bias. Okay, and in algebra, to understand, if you understand this, econometrics master. So what we observe is this green apple and orange, what we observe. And how to make sure you understand this, we make some rearrangement. Plus, minus a red apple and plus a red apple. The same, right? Cancel out. But we just plus a red apple, minus a red apple. Minus and plus. Then this part called treatment effect. That's a green apple minus red apple. Same apples. And this one bothers us, bias. The red apple, counterfactual. What's the counterfactual difference between this orange? Understand? So this is from the algebra. You artificially add minus that counterfactual, add the counterfactual. Then you have two terms. The upper is the real treatment. This is control. This is bias. So that's the algebra. In this way, graphic way, is suddenly in a dream come to this, right? This is not real. And we need this. We don't want this. But in reality, we only have this. So that's of course, this is such a challenge. Of course, this is a challenge. Everyone knows it's a challenge. And then very smart people came up with techniques to make sure we can achieve. And so basically, as I mentioned, this is counterfactual. The point of this is to make an apple to orange comparison to an apple to apple comparison. So that's the key. Without doing so, cannot argue your causal inference. And then now, because some of you, it seems that you understand this. And then what are the things? Why there is such a bother as the bias? What are the challenges to this? We call a terminology called endogeneity. It's endogeneity called this challenge to causal inference. If we can really observe two apples, no endogeneity, immediately estimate. In reality, we cannot. And then what are the real challenges? Anyone know? Some examples? Think about the green building thing. Let's use a real example to see. Why there are some things that bother us, that make this bias exist. This is a non-green building, this is a green building. Both are non-green building, but why there's a difference? Think about this. Go ahead.
About relevant comparative data, so there would be other factors such as the location might be different to the market approach, it can be different or something like that could affect our observation. It's not relevant to what we have.
Can you, this is too abstract. Can you make this very intuitive? Green building. Lead building, yeah.
And then if you're observing a building in Boston and another building in New York, the market factors would be different. So it's not really an apples-to-apples comparison because the location is a different component.
Yeah, but always if we really do this green building premium estimation, we don't go to two markets, gather some data from New York, gather from Boston. For example, we're all from Boston. And then, is there any problem for that? Still different neighborhoods, right? Still neighborhoods, because maybe some rich people live in this area, some poor people live in that area, and for poor people, the green is nothing. They want space. They don't care about the environmental things first. Okay, this give you this green building. And other things, any possible other way, because it's some difference you cannot observe. That's called omitted variables. And what other else things? Besides omitted variables, anything you can imagine?
Yes, the building, the tenant always have high rent, and also the brown building has the
low rent.
Actually, the office tenants, like headquarter or company, really like to together at the same level. So they will prefer to, if they prefer to the high rent, maybe surrounded and this building total like some the same standard like a high rent.
Yeah, but that's not the buyer thing, right? That's what we want to see.
Yeah, actually, if the buyers about the brown building, make the difference related with the company.
Okay, related to company, yes, good. So not just the location, but also the company, right? Some big companies, they really value their image, so this is for you. Okay, now I'm gonna say these very complicated terminologies, but don't be scared. So in econometrics, we run model y as a function of some other things. We call this treatment, the thing we are most interested in is d. D equals 1 is treated, otherwise d equals 0. So this is lead or not. All these other variables are these controls are in x as a vector. So this endogeneity means there's something in the trash can. This is a trash can, remember? Always you have a trash can. And the trash can and the treated variable, they're correlated. They're correlated, they're not independent. If the trash can has so many things in the trash can, but the trash can has nothing to do with the treated, then you won't need to worry. But if they are correlated, worry. And 3 types. Just now we already talked a lot of meter variables, either from the location or from the company. So basically, there's so many things you cannot observe. And a big company build this, a small company invest in this, and this is a nice model, it's a poor neighborhood, all the things. And the second one is called reverse causality. Reverse causality is the story we want to tell is from the right-hand side to the left-hand side, right? That's a regression point. If it's treated, if this green was a premium, so that's from right-hand side to left-hand side. Unfortunately, there is another channel from left-hand side to the right-hand side. For example, for those very expensive buildings, because of the location or because of anything, so expensive and charge so high rent or price, not because of the energy-related things, but just they collect so much revenue, and the board of that company say, oh, we have so much revenue, let's renovate, right? If you cannot charge enough, then you have money, you need to cover daily things. Now, for the very expensive buildings, they have a lot of revenue, then they decide to treat. Not because they treat, then become higher, but it's because they collect more revenue, then they decide to treat. That's opposite to what we want to say. We want to estimate. So that calls reverse causality. The third thing is called selection bias. That's called selected sample. So the sample you selected, you collect, is not representative of the entire market. For example, if we say, oh, let's estimate the green premium, the green price premium for green buildings. Then you go to 0 and you collect. However, we know the transactions for the new houses, you always transacted. For the old houses, it's not always low frequency. Then for the transaction sample you collect is not the representative of the entire housing stock. You always have more new ones transacted, less old ones transacted. So then you have a selected bias because you use a selected sample to estimate this. I'm not sure whether you, so basically this is not underlying population. So that's called selection bias. All 3 reasons will always cause this problem of called endogeneity. So this is conceptual level. And there's so many technologies. And then we need to do apple-to-apple comparison. So the apple-to-apple comparison, there's some techniques. The economists and the econometrics scholars already developed. Anyone knows any names of them? This kind of how to get to apple-to-apple. Is there any terminologies? I feel like you understand. Yeah, please.
You can use, let's see, what would be good. I mean, you could do maybe like a regression discontinuity.
Okay, good. That's one example. Do you have a thing I give you?
No.
No? Okay, this one is for you. Okay. Mackenzie said regression discontinuity, yes. But maybe you don't know what this and other terminologies? Yes. From your RA work for me, you know something. Please.
Instrument variable.
What's that?
Instrumental variable.
Instrumental variable. Yes. Since I already paid your RA, so no fruit. Okay, fine. Okay, because you learned the knowledge from me. Okay, good. But it's so many things, so many technologies, not for you to understand. If you understand this, graduate from the econ department, master's degree or PhD. So yes, even after PhD, I still cannot do this. So the thing is, it's so small, but I give you a sense of this. It's fascinating. There's so many good technologies. One the big category is the following. At first, we come from some naive ways. Naive ways will be accuracy responsibility, not naive, right? Basic, not naive. Accuracy is very high level. So he will teach you OLS, which is a basic regression. Even for basic regression, we have ways to control. For example, so-called fixed effect, right? So, but I don't need to go to that. But anyway, if you do R, basic, we call it OLS, auto release square. So that's the same. Then at least you can try your best to put all enough controls, all the data, right? If you have so many controls, put and have the other ways. And then move on, more advanced to solve this apple-to-apple comparison thing, to achieve this apple-to-apple. I have some more. The thing is the following. The golden way, so-called RCT, that's called randomized control trial, RCT. That's really you do an experiment. You do experiment like in a lab. Then you really observe. It's not like you just observe from the real world. You do a lab thing, RCT. And if you cannot do an experiment is very hard to run. And then you have quasi-experiment, like half, partially. Then you have some things. Today I will talk a little bit about one advanced, which is called matching. You match. And then, just now Mackenzie said this regression discontinuity. That's later, maybe in our later sections of the climate, we will have that. And Wilson said the instrumental variable, right? And another is called difference in differences. So this one, DID, always use. I'm a DID master. I always use DID, and I will teach you how to do DID for climate. The impact of climate risk on housing prices. That's for later session. But today, matching. Matching is very easy and not that difficult one to understand. But the golden way is to do experiment. So experiment, let me give you a sample idea of the experiment. Remember Juan's lecture on healthy buildings. I think he mentioned a little bit of healthy buildings. So for example, we have a very healthy building, CO2 concentrations 800 ppm, that's really healthy. This is one, unhealthy, all the CO2 concentration. Then you have students. You have students, you. And then we are not going to tell you which are which. Two classrooms. One is healthy, the other is unhealthy. We randomly allocate half of you to one classroom, the other half of you to the other classroom. You don't know, and you don't understand why. Then we do our final exam, mid-exam or final exam. Then you do. And then we compare. We compare because we randomized all of you, and your other attributes should not have a systematic difference, right? Of course, each of you are different. But when randomized, non-difference. And only different will be this healthy and unhealthy. Then we measure these biological things, and your heartbeat, and all the cognitive performance, and your test score. So this kind of way was used very widely if the researchers have enough resources. It's very hard. How can you get permission from MIT Institute to randomize you, put half of you to a very unhealthy place? Ethical problem, right? And but if this is manageable, this is the golden way to get apple to apple because it's totally randomized apple to apple. Then you compare. For example, primary elementary school, right? Elementary school, then you put some air filters. For example, it's a developing country like China, very polluted. And then for elementary school, it's many classrooms. You put some very good air filters in some classroom, help clean the air inside. Put others, we call it placebo. Also similar thing, machine, and the kids, they don't understand the difference. But it's not a real filter, but it's placebo. And then you randomly put the students in those classrooms. After some days, you observe. So that's called the experiment. That's so hard. You must have the collaboration with the elementary school, Ministry of Education, like that consent and the parents and all the things, right? So that's why Well, if you do experiment, you publish very well. That's all our scholars dream, to do experiment and publish well, because so hard. For example, we did one in pandemic together, my lab's team, including several researchers, and we did one, it's published in a very top journal, Peanuts. That's basically you randomize people, give them different information, and observe their behaviors. I don't want to go to details, but I just want to let you know. And do you know two very famous professors, MIT Econ Department? They got Nobel Prize because of this randomized control trial in developing countries. Who knows their name? Yes.
Her husband.
And her husband. Yes, very good. How did you know them?
From India?
Oh, yes, they are doing project in India. Yeah. So there's a couple, power couple of two professors. They are the husband and wife, Duflo and Banjani. They won Nobel Prize for this. They did all kinds of things in India and other countries. So, golden. We are common people. We cannot do that every day. So we need to rely on other technologies. Now, I'm going to tell you, as a common people, student or researcher, we don't need to do all those perfect things, but at least we can do something. The thing I want you to learn from today's class is we need to try. We cannot say, I don't care. I just observe correlation, then done. No, that's not rigorous. As an MIT student, rigorous, and say, we understand. If we just do a naive regression, get the coefficient of a variable, green, not real. There's omitted variables. There's endogeneity problem. It's not a causal inference. How to do? Then I'm going to talk matching. Match. I have so many. And then apple to apple. Twins, that's perfect. Some scholars, they did do that. They track the twins. The twins, they were born, right? Same parent, same environment, like that. And later, different outcomes because of the environment. When a boy went to this city, the girl to that city, and the environment, then the long-term, lifetime outcomes. Hard. One thing is geographic matching. So matching. Twins are also matching, but the natural matching. And a more advanced called propensity score matching. I'm going to skip this, but I will talk about a little bit. PSM is advanced matching, but the thing is geographic matching that's very well widely used in the real estate market, right? Because we are location things. So I think some of you already mentioned this. If there's a green building, you're not going to compare a green building in this location to a green building in totally a different location. Like this is Boston downtown, right? This is a green building, and then you find another place in a suburban some place. No. Compare this green building with nearby non-green building, very close nearby. That's called geographic matching. Say 0.2 square miles, this circle. So that was what they did. That was that paper, remember the early paper? They did this. They did, after this match, they found, become so similar. The class A, both are 75%. One 75%, the other 71%. Of course, not like perfect matching. But if you get the green building and the two brown buildings so nearby, so same location, and will be similar. Then they're not going to do this in a suburban area to compare. No. Get this and nearby buildings, then this is treated, this is control, then they compare. So that's basically matching. So this is not difficult. After matching, they say, I'm more confident. The author said, we are more confident we are estimating some apple-to-apple thing. This is the green rating, rent 2.6% premium, and sale price 13.3% premium. Effective rent is 7.6 premium. So after matching, they are more confident on this difference instead of a random other place. So that's the matching thing. Okay, now I'm gonna do more of this. Is think about this. So now we understand there's so much difficulties. There's a causal inference, and we need some techniques to do apple to apple. I want you further understand the truth, the root of why we have problems. I will go back to this naive example. This naive example when I introduced hedonic. Decompose, right? Decompose, remember? 1 million house, 1, 2, 3, 4 components, plus a trash can. That's this hedonic thing. How to think about this buyer thing in a hedonic setting? That's the point. Let me see. Okay, just now I showed this. This is all the same. Okay, now, suppose in the trash can, although we cannot measure, but we understand from our intuition, we understand the trash can is something called fancy. Fancy. The fancy, of course, is so hard to measure how fancy like this, like that, right? But we know some buildings are fancier, some other buildings are less fancy. And then we cannot measure, but we know there's something here. And maybe the fancy thing is correlated with lead. Like the lead building, if the famous designer, then the fancier, right? Some of you went to New York City, and together with you, we saw some like very fancy buildings. So these are correlated. If these are correlated and you cannot observe fancy in that trash can, problem. Suppose if we could observe fancy, that fancy is 0.05 million. Suppose we could. That's a hypothetical thing. Actually, we couldn't, but suppose. And then, let me see. If we can, so fortunately we can have a measure of fancy, then no problem. We decompose the trash can to a real fancy and the leftover trash can. Okay, then everything's done. Good. Then this one is good. However, in reality, we cannot observe. And to the extreme case, suppose the fancy, basically, all lead buildings are fancier. All non-lead buildings are non-fancy. And we couldn't, then we wrongly estimate this, overestimate, because all the lead buildings are fancier, right? So you will see all the lead buildings are 0.15 million more, but the real lead is 1.1. And because the fancier, they are so correlated, 100% perfectly correlated, then all the lead buildings are fancy buildings. So you bundle them together, you cannot separate, and you cannot observe. Then you overestimate the lead, become 0.15 million. Is that clear? That's a problem. So all the things you cannot observe, if in the residual, they are correlated with your interest of the variable of interest, then you overestimate or underestimate. This case is overestimate. So that's a problem. Any questions here? So I want to use this to show you, because just now I know it's very abstract in this way. Let me see. Yeah. Remember this way? Algebra, so abstract. At that time, I said, endogeneity is the trash can got correlated with D. The D is the green, right? But from algebra, maybe you feel so abstract. So I just now use this fancy way to show you the trash can, something in the trash can got correlated, then problem. You cannot observe, you bundle them together, you estimate a bigger thing, which is not real. Okay, so the thing, again, think about this, apple to orange. As we observe a lead building and a brown building, lead fancy, brown building non-fancy, the difference is 0.15 million. Naive, this is very naive, not red. We need to get this another apple, which is apple to apple, and then, because this two is like this, right? Fancier, green, non-fancy, non-green, not right. And we need to get the counterfactual, which is also fancy. right? And non-green. Then we calculate real. And then that's an issue. It's not that difficult, then you match. Suppose that neighborhood are all fancy, right? That's our assumption. Suppose geography matching, we suppose this neighborhood are all fancy buildings. So we compare, then we rule out the fancy factor, and we get the green factor. Oh, I hope you understand. Hopefully. And then, okay, now move on a little bit. Given all your, if you understand all this, so easy to extend to cities. That's why I've spent so much time to understand this. Now, think about cities. Cities, the same thing, hedonic. And then in that thing, remember just now, we had all the attributes in X1, which is building attributes. Green or not, how many rooms, like that. There's another factor we call the locational things. That's also important. Then you decompose locational things. You buy a house not because you only need the space, you also want to be a good school district. That's why I bought my house in Lexington. In the first place, at that time I knew nothing about this city. I asked ZZ for advice. ZZ told me several good towns with good schools. One is Lexington. Then that's why I got Lexington. I think my first priority is to send my son to a good school so that he later can get at least to a college. College. Okay. So that's good. Subway, important transportation. Green Park, air pollution. No one wants to live in close to a factory, I think. Unless you don't know, that's a problem. So if you decompose similar things as what we did, green space, clean air, walkability, other things, estimate. This slide can summarize many past faculty research. Our urban study and planning. We have a transportation, Chris Douglas and Jinghua Zhao, 2 professors, 3 Professor Fabio. If they have the data, they estimate, oh, subway is important, right? People, public transit. They need to come to Siqi. They don't know how to do it. They come to Siqi and say, oh, can you give me some housing transaction data? Yes, no problem. I give them data. Then they use housing transactions to run the model, then they estimate the price premium of the subway station or bus stop, no matter what, premium. Good. Then we publish a paper. Okay, next day, a professor called Mariana Akea came. Siqi, I want to work with you. Housing transaction, estimate the green parks. That's a health effect. Why people want to live close to a park or do easier to exercise, or the air pollution, good for their health, they have willingness to pay. Okay, because this is bad thing. If you bad thing, negative. Okay, it's not like all the coefficients are positive. That matters, depends on how you measure that thing. The positive thing, we call it positive amenities. Negative thing, we call negative amenities. Air pollution is negative amenity, so that's why it's negative. Okay, then we use this to do and have a published paper, public house. So that's kind of, and I myself was so interested in school. Not just because of my son, but I just want to understand the school premium in the housing price. I did several papers using China's data. This is real data I estimated. A good school district, 8% price premium. So that's my real paper. So that's all cities, right? I just want to showcase my paper. You don't need to get into this. So I just want to tell a story. At first, I didn't know how to do this. When I came here, 2005, as a visiting scholar, I randomly ran into a professor. That professor is my co-author. My co-author told me, oh, you cannot just look at real estate as inside the real estate. Real estate is very useful for other things. Study other things using real estate as a channel, as a tool. Real estate is a tool. Housing is a tool instead of your destination. Because people choose where to live, where to work, and where to play through real estate. And many things cannot observe. You use real estate to back out people's willingness to pay for so many things. I think, good, let's work together. Then we produced this paper. And that paper using Beijing transaction data, that's many years ago when I was just graduate student. So I collect all the data transactions. with 920 transactions. At that time, I learned GIS. At first, I didn't know. Now I learned GIS, GL code these things. That's at that time. And land, and the subway, and bus stops, I GL code all the subway stops. Crime, high crime areas, good schools, very concentrated in that contact. And major universities. University also good, right? Everyone wants to live in close, then you have all this human capital. And environmental amenities like here, this air pollution, bad air pollution, good air pollution, and park, big parks. I collect all this, I work day and night. So that's something I want to tell another small story. When I was young, now I'm not that old, but when I was relatively young, I worked so hard on these things. And I stayed up very late to collect data, GL code, run regression. And I understand the hedonic. And later, when I become more senior as a professor, I have my students. I ask my students to do, but I understand the rationale. Why I tell this story? Because many of you may think, oh, this is too technical. I like, oh, I don't need to run regression. I don't want to do the p-set. But if you do the p-set right now, later you become a senior manager or boss, and you know how your employees are doing. Right? You can point out, oh, you didn't consider this objective variable. Did you consider fancy? Did you consider this and that? This estimate is not right. I know, because back to MIT, I learned that from Siqi's class, this apple-to-apple comparison. You are not doing apple-to-apple. So now don't think that later you will be so senior you don't need to understand this. Today you understand. Later you can advise your employees in a high level. So that's why I'm doing. Now I don't run those kind of things, but because I run this and stay up late, run this 20 years ago, now I understand very well. No my student can cheat me. Everything point out. So that's why I want you to do your p-sets. Okay, at that time I was so junior, the other professor so senior, he said, you run this, you do this, you do this. I did. And then I did this. That's right. You must go through that process. Right? Then I collect all data. At that time, not that easy to get this data from China. So I got all the data. I learned GIS, I GL code, I run regression. I learned at that time data, not R. So I did this. Okay. Finally, I'm not going to talk hard work. I'm going to talk some fun stuff. Many of us, we went to New York City with Kairos. And we visited so many projects. And I went there one night before because I didn't want to take the bus early morning. So I went there the day before. I enjoyed some Broadway show and other things. And the other morning, I walked around. I walked through this park. I walked by this park because I knew I'm going to study this. And the other one is Highland, right? So some of you told me where is the Highland Park. So I want to use this example. So this Brand Park is very close by to our first visit, Rockefeller Center, I walked through. And it's not always fancy. Now it's fancy. I looked through this. Now it's fancy. But back to 1980s, 1970s, it was very poorly managed. The city ran out of money. New York City ran out of money of maintaining all the parks in New York City. They almost gave up this park. At that time, crime and drug trade and crime and all this trash all over the place. So that suffered so much. And then the city ran out of money, no public money. They're going to give up. Then the people around, communities, those buildings, the companies and some communities nearby, they self-organized together. They went to the government. They negotiate with government, say, we can do this. Okay, you don't have money? We are going to do. They organize restoration association of this park, and they collect money, each one contribute a little bit into a pool, and they get a 15-year long-term lease from the government. And then later they extend to another 5 years. And then they immediately shut down the park and they start the restoration. They start redevelopment of that. And after 5 years, reopened. and become very good place, and people stay here, winter shops, and the summer all this concert. And then the nearby housing got appreciation. So that's a way. Why this nearby? There's a company called Grace Building Company, that's an office building nearby. At that time, they put in how many $1 million, I forgot the number, into that pool. With the expectation, later become from a negative amenity, ugly, to a positive amenity, increase the appreciation value of the office building, they get money back. So that's why they are willing to put money first in. So that's a rationale. Not like all are philosophic, but also this price appreciation. And then during the recession, the financial crisis, all my office buildings in Manhattan suffered, but they kept relatively higher occupancy rate and higher rent at that time. So that's an example of the private-public partnership. Then they went to the city and say, we continue to rent this park, and we have our civic group to run instead of using money. And New York City learned this lesson from this park. And then from that time, they didn't put all their own money. They always partner with a private sector group or the community group to do this maintenance. I think many of us, we went to New York City, and Carol brought us to 5 mixed-use projects, right, remember? And we know it's mixed-use projects always is a collaboration between the government and the city, between the city and the private developer and owner. So that's a way. And then, of course, this is very clear. And I think Carol mentioned a lot about this in the through class if you are there. But from my side, I want you to understand scientific. When you think about future, in your mind, no matter whether quantitative or quantitative in your mind, if you later become a decision maker, whether there's some group come to you, can you give us money to the pool and we will do this and that, nearby street, beauty find nearby neighborhood, then how much money you are going to give? You estimate, right? In your mind, you run a quick conceptual level hedonic model. Then, okay, the park here. Then the park is green park, better park. That will increase my property's value by how much? Then I compare, right? Even conceptual level, that's important. Instead of say, oh, even the park has nothing to do with me. Then that's basically in the business decision making. I did this. This is like a consultancy project when I was in China. A city is going to build a subway network. They are going to partner with the private sector. It's a Hong Kong subway company to build the subway. They want to understand how much money they are going to invest and how much money they want that Hong Kong company to invest. They promised to the Hong Kong company if they build a subway, invest, they will get some land around subway stations. That's called TOD. If you invest, the Hong Kong company invest money to build a subway, they get some land parcels around, and they can build real estate later. So that's always a Hong Kong model of the subway building, subway construction. Then I say, no problem, Siqi, hedonic master. I run hedonic. And I tell them, okay, after the subway, the price premium, 0.5 kilometer circle, 14%. 0.5 to 1, 7.5%. We estimate benefit this. And I estimate if the Hong Kong company can get land parcels around, they can get benefit of what? And then they say, oh, I understand. The Hong Kong company, you need to invest this money in this so that I can give you real estate. So that's a final way. Okay, Highland Park. At first I learned this from Google, then I went to New York City, you showed me Highland Park. So that's a thing, right? At first, it was relatively not that developed, that area in the West Chelsea, right? West Chelsea, Manhattan. Some like low-end shops around, but some relatively middle to low-income people, they have small houses nearby. The city upgrade to Highland Park. And then think about WPP. Finally, WPP. We go back to WTP. At first, like this blue line, right? This is Highland Park or any green space. The blue line is willing to pay. It's closer, pay higher. the firewall is lower. But because that, at that time it's just an abandoned railway, not that good. So it's very flat. Then the city invests money, build this Highland Park, and then become so fancy, and then become the richer household. They're willing to live nearby, and some hotels and restaurants nearby. Then willing to pay this distance to the Highland Park become like this. So that's the rationale. But think about the final angle is environmental gentrification. So the good thing is the city become beautiful, Highland Park. However, inevitably, the red line, rich people's willing to pay to be close, much higher than the original residents. They bought in, they squeeze out, they push out other. So this is called gentrification. So it's always no free lunch. If they're green amenity, gentrification, rich people who have higher willingness to pay occupy. Poor people move out from small shops into fancy restaurant and hotel, 5-star hotels. So that's a debate. Later we can discuss this, but that's a debate, not like, oh, everything's so good, invest, then housing price go up. If you go to this urban planning department, you need to think about this, gentrification. Okay, so I think that's how I managed to finish, and I'm gonna give this. Thank you so much. And I will give to 3 people on the front line because I want you to sit front. Okay, see you next time.